Okay, here we are then, example 11. It's the second example to go with section 7.5. And let's go through this in the usual way. Pick out the key information in the question. So we've got a box of mass 2 kilograms. It's pushed up a rough plane. It's pushed by a horizontal force of 25 newtons. The plane is inclined to the horizontal at an angle of 10 degrees. The coefficient of friction between the box and the plane is 0.3. Find the acceleration of the box. Okay, so let's get that on a diagram in the usual way. We've got an angle of 10 degrees. That's the angle of inclination. We've got a box of mass 2 kilograms, so we've got a weight of 2g. It's pushed up, so there must be the friction is acting down the plane by a force of magnitude 25 newtons. So let's just check if there's an angle of that. So a box of mass 2 kilograms is pushed up a rough plane by a horizontal force. The plane is inclined at the horizontal angle of 10 degrees. Find the coefficient of friction. So the force is of 25 newtons, but it's horizontal. It's a horizontal force. So we've got a force here acting on the particle, which is 25 newtons. And then the plane is inclined, blah, blah, blah. Mu is equal to 0.3, and we're asked to find the acceleration of the box. So what force is missing? We've got the normal reaction, which is missing, and we should acknowledge that the acceleration is up the plane, which is what we're trying to find. So it is the standard approach. We're going to look at these forces and we're going to work parallel and perpendicular to the plane in the usual way. So first of all, let's apply N2 up the plane and parallel to the plane. So what are the forces in that direction? So we need to break our forces down into their components. Let's first of all put the angle on here. So this is also 10 degrees. So next to that, we've got a force acting perpendicular to the plane. So that will be 2g cos of 10 degrees. And similarly here, we're going to have that angle in here will also be 10 degrees because these two here are corresponding because those two lines are parallel. Yeah. Opposite then. So this will be opposite the angle, so it's going to be sine. So this will be 25. Opposite is sine of 10. Okay, now let's work parallel to the plane. Here, the two forces, remember, add up to make the magnitude. And we get 2g opposite, so it's going to be sine of 10 degrees. And here, it's next to, so this is 25 cos of 10 degrees. So now we can look at those that are acting parallel to the plane. So we've got this one and this one are in our parallel direction. Is there anything else there? Have I missed anything? Yep, the friction. There we go. So now we know the three things that we're looking at. We're taking up the plane as positive. So we've got 25. Let's get back into the black. 25 cos of 10 degrees minus 2g sine of 10 minus the friction is equal to the mass times the acceleration. And we know the mass, so we can actually write it in. We know the mass is 2. Okay, I'm just going to rearrange that to make friction the subject, because we know that later on we're likely to have to use friction is equal to mu r. So we get 25 cos of 10 minus 2g sine of 10 minus 2a is equal to the friction. Okay, now let's resolve perpendicular to the plane, because that's the next usual step and we've got no reason not to follow it. So we now need to go back to our diagram and identify the forces acting in that direction. So acting in that direction, we've got R, and we've got these 25 sine 10 and this 2g cos 10. So if we pick those out, resolve perpendicular to the plane, we've got R is plus minus the 2g cos of 10, because that's down, and minus 25 sine of 10 will equal 0, since it's in equilibrium in that direction. So that was lifting out the pink bits. And just to go back, not that you need necessarily to have this, but just to make it clear that that came from the highlighted red bits. Okay. Now, just like above, we made friction the subject, so let's make R the subject here. So R is equal to 2g cos of 10, adding it across, plus 2 sine, oh, not 2, that's 25, isn't it? 25 sine of 10. Okay, sliding. So since sliding, friction is equal to mu r, and we can now substitute from above. So we get 25 cos of 10 minus 2g sine of 10 minus 2a equals mu, which is going to come from the question, 3/10 or 0.3 times r, which is 2g cos of 10 plus 25 sine of 10. Okay, so now all we've got to do is collect these together in the right way, because there's now only one unknown left in the equation that we're trying to find, and that is the a. So let's make that positive, add the 2a across, and then on this left-hand side we're going to have 25 cos of 10 minus 2g sine of 10 from above, and then we're going to have to subtract the rest of it from the right-hand side. So minus 3/10 of 2g cos of 10 plus 25 sine of 10. And really it's pretty much a calculator activity at that point. So if we tap that left-hand side in, 2a, you should get 14.1 meters per second squared, and then a divided by 2, so it's going to come out to be roughly 7 meters per second squared for the acceleration. You can check that exactly on the calculator, but it should be around there. Okay, so homework then that's attached with that section. Exercise 7E, questions 3, 4, 7, 8, 9 and 11 should be enough. Okay, good luck with those, and I will try and get the next section up tomorrow so that we're ready to keep moving forwards.